Hi, everybody. It's Miss Rose. There's going to be times this school year that we provide you with video lessons, and we'll want you to take good notes so that you can take those notes and apply what you learned to some homework assignments. So we want to give that a try today with our first big lesson of the school year, where we're going to start learning about points. Points are things that you learned about in algebra class, but they're also really important in geometry class. So you're going to see some vocabulary that hopefully looks familiar to you, like quadrant, origin, slope. If those things don't look familiar to you, I'm going to refresh your memory on them. And then there's a word that's probably brand new to you because this might be more of a geometry word, and it's collinear. It looks intimidating at first, but if you look closely inside the word, you'll see something familiar. You'll see the word line. So I will explain to you what that means in a minute. Let's look at some examples. Example number 1 refers to plotting points. So let's refresh our memory on how to plot points. You have an x coordinate and a y coordinate every time you plot a point. And on a graph, you have an x-axis and a y-axis. Sometimes I remember that the x-axis is a horizontal one because that goes across and you cross your x's. So if that's helpful, then you can use it. When you're looking in ordered pair, the numbers go in alphabetical order. So it's X first and then Y. So you go either right or left for the first number, up or down for the second number. The origin, which was one of those vocabulary words, that's the starting point. So you start at the origin. You picture like if you're playing a board game, that's where your piece starts. And then you would count, if I'm plotting point A, I'd count 6 to the left because it's -6, and then 5 up. So starting at the origin, I count left 6, up 5, I draw a dot, that's a point. And the way in geometry that we're going to label points is with a capital letter. So that's capital letter A. Point B, we're going to start at the origin, and it's +2, so we're going to count to the right 2, and then -3, so down 3. And then I'm going to label that with a capital letter B. And then point C is 7, 0. So starting at the origin, I'm going to go to the right 7 because it's +7 on the x-axis, and then I'm going to go up 0. And that is my C. All right, that was thing number 1, plot each point. Thing number 2 is tell which quadrant each point is in. So let me refresh your memory on quadrant. Quad means 4. You can see that the graph is split up into 4 sections. So it might not start where you're expecting it to. The first quadrant is where everything is positive, where X is positive and where Y is positive. So this right here is the first quadrant. For some reason, we use Roman numerals when we're talking about quadrants. This one over to the left, we're going to go counterclockwise. We're going to go around this way when we label. So this one to the left with negative x's and positive y's is quadrant 2. And you'll see that's where point A is. So quadrant 2. Then I'm going to keep going around. This is quadrant 3 and quadrant 4. Oh, there's point B, quadrant 4. Where does C lie? Because it's like halfway in between quadrant 1 and quadrant 4. Well, C is actually on the x-axis, so we wouldn't say that that's in a quadrant. So you could either say none, or you could say it lies on the x-axis. So that's a little review on quadrants. Then here's our new word. Finally, the last part of this says, determine whether or not the points are collinear. So that means if you drew a line, would the line pass through all 3 points? And I would say for these ones, definitely not. If I draw a line through A and B, C is definitely not on that line. 2 points are always collinear, but the question is, does the third point lie on that line also? And in this one, I'm going to say no, and I can say A, B, and C are not collinear. If I had to explain my answer, I would say something like, because they do not lie in a line. So that would be a good explanation for that one. All right, let's try one more of those. Let's plot a few more points. This time I called them D, E, and F. So starting at the origin again, origin, that's always your starting point. Count to the left 2 and up 1. That's point D. What quadrant is that in? 1, 2. All right, next, E is over to the right 2 and up 3 from the origin. What quadrant is that in? It's the first one where X and Y are both positive. And then F is 4, 4. E is kind of in the way. I'm going to move it. 4, 4 is F. Oh, that's also in the first quadrant. All right, do those 3 points lie in a line? It looks like it, but I don't know that it looks like it is the most mathematical way to tell for sure. So what we're going to use to tell for sure is the slope. So if you remember from algebra, the slope is the rise and run that it takes to get from one point to the other. So the slope, I'm going to use M for slope, like a mountain slope. The slope of DE, to get from D to E, I went up 2 boxes and over 4 boxes. The slope from E to F, I go up 1 over 2. So slope EF, up 1 over 2. We want to know if those slopes are the same. If the slopes are the same, then the points are collinear. So at first glance, they don't look like they're the same, but 2/4 can be simplified. I could go 2 divided by 2 is 1, and 4 divided by 2 is 2. 2 out of 4 is the same as a half. So see how the slopes are the same? So yes, D, E, and F are collinear. I would say there's 2 good ways to explain that. You could either say they all lie on the same line, or you could say the slope of DE is the same as the slope of EF. And that is why they are collinear. All right, let's look at 2 more examples. So this next one is also determine whether or not the points are collinear. Well, what's different about this one than the last one is we don't have a graph, so I can't just eyeball them and say, oh, they all lie on the same line. So you notice that I used capital letters to label the points on the previous problems. Let's use capital letters for these ones also. So what we want to check is what's the slope of AB, and then what's the slope of BC. I can pick any of the 2 points, but I usually just go from A to B and B to C and see if the slopes are the same. So remember from what we practiced previously, the slope is y2 minus y1 over x2 minus x1. So I can kind of label those and go y2 is 10 minus y1 is 7, x2 19 minus x1 is 11. 10 minus 7 is 3. 19 minus 11 is 8. And that cannot be simplified. All right, the slope of BC, now we're going to use these 2 points. And I guess this time we'll do like y3 minus y2. So let's go 16 minus 10 and 35 minus 19. That's 6 over 16. It's just like the last time where at first glance they don't look the same, but if I simplify 6/16, I'll get 3/8. So are these points collinear? Yes. They are collinear. They all lie on the same line. The slope from A to B is the same as the slope from B to C. Let's try one more thing. This one's a little bit more of a challenge. This one, I'm telling you this time that these 3 points are collinear. Can you find the value of y? So let's label them A, B, and C again, because that seems like a good way to start. And what we learned was the slope of AB has to be the same as the slope of BC. So if I don't know how to start a problem, I just kind of go with what I know. Collinear, this is what I did the last time, even though this problem's different. I'll label the points with letters and start finding some slopes. So the slope of AB is -3 minus -7 over 4 minus -1. Be really careful with your negatives here. Use a calculator if you want to do the arithmetic. -3 minus -7 is 4. 4 minus -1 is 5. So the slope of AB is 4/5. What's the slope of BC? Well, this is kind of weird because the y coordinate is y. So y minus -3 over 19 minus 4. So y minus negative 3, that's the same as y plus 3. And then 19 minus 4 is 15. So what do I do now? Because I have to figure out what y is. So remember that collinear means all the points lie on the same line, which means the slope from A to B has to be the same or equal to the slope from B to C. So we actually have a little equation that you can solve. And there's a few different methods for solving this one. So 4/5 equals y plus 3 over 15. I'm going to show you one way to solve this that I think is kind of clever. If you don't like that, we can review another way to solve it, which involves cross multiplying. But what I noticed that there's a 15 in the denominator of this fraction and a 5 in the denominator of this one. So I thought, why don't I just make those equivalent? Remember, with fractions, you can multiply the numerator and the denominator by the same number, and it stays equivalent to what you started with. So that turns that fraction into 12/15. And if you have two fractions with the same denominator, that means the numerators need to be equivalent to each other also if those two fractions are equal to each other. So I can just solve a really quick equation where I set the numerators equal. And to solve for y, either you know what plus 3 equals 12, or we can do a quick little algebraic step to get y equals 9. So that's our final answer. So if I go back to what I started with, that means 19 comma 9 lies on the same line as those other 2 points. We can go over a couple of other methods for solving that in class too, but I kind of liked this one as a way to start. So let us know what questions you have. Hopefully you took some good notes, and we're going to put this into practice in a couple more lessons and assignments today.